Okay, guys, now we're going to begin Chapter 3. Chapter 2, we spent talking about solving all different kinds of equations. In Chapter 3, we're going to focus on functions. So just like when we started solving equations, we started with the next to most simple. The simplest is linear, of course, but we started with quadratic equations. So we're going to start with quadratic functions. Now, the difference between an equation and a function, remember when we had an equation, this ax squared plus bx plus c, we had equals 0. So all we had was one variable. Now, though, we've got ax squared plus bx plus c equals y, right? Our function notation, that means this is a y. So when I have an x and a y, I can no longer solve it just for a single numerical value like we could do if we only had one variable. Remember when you started graphing lines, the whole reason that we started graphing was because I had two variables now, and there's just an infinite number of possibilities. Okay, so same thing here. That means this chapter is going to be a lot of graphing because we're going to have functions. And personally, like I've said before, if I know I'm graphing, right, I might want to change my f of x notation to y. Whatever you prefer. Okay, so we've already taught some about quadratic functions when we did our transformations. So we know that the shape of every quadratic function makes a parabola. And the simplest quadratic function is just your basic x squared, right? So all parabolas are symmetric with respect to this line that goes right through the middle. And this line is called the axis of symmetry. Okay, when we're asked what the axis of symmetry is, because it's an actual line, a vertical line, we can't just say the axis of symmetry is 0. That really doesn't make sense. What do you mean? 0? That's 0, right? So we would say it's the line x equals 0. It's going to be really important to make sure that every time you're asked what's the axis, that you put it in the form of an equation, because the axis is a vertical line. So for this one, for our basic one, it's x equals 0. This point right here, the very bottom or the very top, if your parabola happens to be upside down, is called the vertex. Okay, so that point for the basic parabola, basic quadratic function, is 0, 0. Okay, so all this information is going to be really important to helping us graph equations that aren't of a form, or I guess I should say functions, whatever, that aren't of a form where we could use transformation. So we need to think about the important features of our graph. And this one right here is the most important one, okay, the vertex. Okay, so for this one also, remember what we've talked about a domain. If I'm looking at the domain, I'm thinking about the x values. So if I look across here, look across the x-axis, I come to an arrow first. That means it's going, notice how it's veering this direction as it goes up. It's coming this way, so that's negative infinity. And then there's graph, graph, graph. There's another arrow, meaning it's veering this way as it goes up. So the domain is negative infinity to positive infinity. And the domain of every parabola is negative infinity to positive infinity. So as soon as it asks you about the domain, it's negative infinity to positive infinity, right? Nothing to think about there. And we can tell that from here also. All of our functions domains, unless we had a radical or a denominator with a variable in it, it's negative infinity to infinity. Now the range is going to depend on what our specific equation is, right? And where our vertex falls. The range is asking about the y values. So if I'm looking up the y-axis, on this one in particular, I don't hit graph until I get to 0, right? So 0. And then there's graph all the way up till I see arrows going up forever. So 0 to infinity. Okay, so just keep those concepts of the features of a parabola in mind. Okay, and this is just kind of a review. I'm not going to go over every bit of this. If you want to pause the video and read this, you can, but it's just reviewing what we did a couple of lessons back with the translations and the effects of these different parts of our quadratic. Okay, so let's refresh our memory and graph this thing. It also wants us to give the domain, the range, and the axis of symmetry. Okay, so remember our order that we need to do these things in. Let me come over here. Okay, let's see if I need to, let's make this go by 2's just to make sure we have room to fit what we need. Okay, and we'll just do both of them by 2's. Okay, now remember, if I wanted my basic function, very quickly I'd say, well, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Okay, so right here is my graph. But I really want to graph this thing. So I'm going to take every one of those pieces and I'm going to move it to the right, opposite because it's inside with the x, to the right 4. I'm going to take -1/2 of the y value and move it up 3. So let's start right here. I may not have needed to, just so it's not junked up, I don't think I need that. Let me redo this and see if we can get by without changing my scale, just so we're not jammed up. All right, so in that case, if I'm not going to change my scale, I've got -2 squared is 4, -1 squared is 1, and again, hopefully by now we can just get these points, boom, 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 like that. Okay, so I'm going to take every point and move it right 4. Yeah, I know I'm going to get in a little trouble there, but we'll get most of it. Okay, so 1, 2, 3, 4. Okay, I'm going to multiply the y value by -1/2. Since my y value is 4, -1/2 is -2. But then I'm going to go up 3. 1, 2, 3. Again, if you need to do it in steps, each piece, that's fine. Just pay attention to which one's actually a point on the graph. Okay, same thing here. I'm going to go right 4. 1, 2, 3, 4. My y value is 1. So 1 times -1/2 is -1. -1/2. And then up 3. So 1, 2, 3. Okay. I'm going to go right 4. 1, 2, 3, 4. Okay. -1/2 times 0 is still 0. So up 3. 1, 2, 3. And now I'm going to take advantage of symmetry just because we're running off of the graph. So I know that there's going to be another point right here, right? And I know there's going to be another over here I'm off the video, over here, right? So then if I were to draw my parabola through here, okay. All right, now the domain, -infinity to infinity. Don't even have to think about it. I could go over there and look at the graph, right? That's not a point. Let me continue that so that we don't mistakenly think it stops there. Well, if we're looking at that. Okay, the range in this case, because it's upside down, the first thing I come to is an arrow going down forever. So the range is -infinity, and then it goes all the way up to this point, which is 4, 3. Right, I don't care what the point is. All the way up to where the y value is 3. And then the axis of symmetry, don't forget it's got to be an equation. The axis of symmetry is the vertical line that goes through that vertex, right? So the axis of symmetry is x equals 4. Let's list what the vertex point is, right? I was just talking about that. It's 4, 3. And let's look at the connections between the vertex and the axis of symmetry and the vertex and the range, right? So really, from now on, I'm probably just going to state my vertex first, and then that's going to help me get the range. Now, all I need to do is know if my parabola opens up or down to know if it's 3 up or negative infinity up to 3, right? And my axis of symmetry is always going to go through that x coordinate of the vertex. Okay, so that's just a refresher, right? We already know how to do that, hopefully. But here's our issue. Here's our problem. Sorry guys, got distracted. A bird is trying to come through my window. I hope he don't hurt himself. Okay. Here is a problem now. It's not really in the right format to use our translations. So one thing I could do is, well, we know how to make something look like it's something all squared, right? We can complete the square. But just like when we did that for the circles, we got to tweak it a little bit. Because the first thing in completing the square is move your constant to the other side. I can't do that, right? I mean, I could, but it would leave me y plus 7. And what is that? That doesn't help me. So I got to leave my constant over here. Leading coefficient's already 1, which is good because it's really crazy if it's not. So I don't have to worry about that. All right, now I'm going to take half of my linear term, half of 6 is 3, and square it. Okay. Sorry, guys. Half of 6 is 3, and square it, which gives me 9. But I don't have my term written here. So I'm going to add 9. And before I would add 9 to both sides. But now, once again, since I don't have a numeral over here that I can combine with that 9 and that 7, I can't add it to this side. So I'm just going to add it and then take it right back off on the same side. Right? So that doesn't, I still have that plus 7 out there. It doesn't change my equation either if I just put a plus 9 minus 9. But it allows me to complete the square, or to factor this, and I know how it factors. Use this sign. I think every single one we've done on these videos had a minus there. It's crazy. Okay, and the half number. And now these I can combine, and voila, we've put it in a form where we could actually graph this thing, right? So I know that my basic points are negative 2 squared is 4, negative 1 squared, 0 squared, 1 squared, 2 squared. Just get them that quick. Okay, so I'm going to take every one of those points and move it right 3 and up 2. Okay, 1, 2, 3, up 2. 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 1, we're going to say 2, 3. I'm not going up 2, I'm going down 2. Are y'all used to me being nutso so far? Yeah. Okay. Watch out for me. Okay, back to what I was saying. Right 3, down 2, right, down 2. So right 3, 1, 2, 3, down 2. Right 3, 1, 2, 3, down 2. 1, 2, 3, down 2. Okay. 1, 2, 3, down 2. And 1, 2, 3, down 2. Okay. Then we can draw our parabola in. Okay, now this one, instead of asking for the axis of symmetry and range and domain, it asks to find the intervals where the function's increasing or decreasing. So it's decreasing right here, right, to this place, to the axis of symmetry. So it's decreasing on the interval, and remember we're still talking about the x, so from when x is negative infinity to, notice the vertex again. It's always great to just, your first step is say, well, my vertex is 1, 2, 3, negative 2. Because that's also going to help me with my increasing and decreasing intervals, and my domain, and my range, and my axis of symmetry. So negative infinity to 3. And then it's increasing from 3 to infinity, right? It's increasing on this side. So from here on, the function is increasing. Okay, so there's an option. We could just complete the square and put it in that form where I can use my transformations. But let's look at, what if that leading coefficient is not 1? All right, so I'm going to make a suggestion to you. Don't take your notes and write this down. Just watch, follow me through this. It's really going to be pretty complicated. And then, though, after we get finished, let's see if we can make some connections to get some shortcuts. Okay, so I'm thinking, oh, I can't graph that thing right now because I can't really figure out what my translations are. So I'm going to complete the square. Now, we already said I can't move that over, so we'll just leave that there. Also, I've got to have this leading coefficient equal to 1. And I can't divide by -3 like I would on a regular equation, again, because there's not a numeral over here that I can combine it with. So instead, I'm just going to factor a -3 out of these first two terms. So there, that looks fun already, right? So factor a -3 out. Okay, now I'm going to try to complete the square on this where my leading coefficient is 1. So I'll have this -3. All right, so I'm going to take half of 2/3, which is 1/3, right? And 1/3 squared is 1/9. So remember, I'm going to add that and then subtract it. Okay, but it's really only this part that makes my perfect square trinomial. So I need, before I did not have parentheses around this, right? Separating this number from this number so I could combine them. So I need that out of there so I can combine it with this other constant term. So everything's the same until there. I'm just going to move that out. But I can't just move my parenthesis. What this number is, if I were to distribute this to get rid of my parentheses, right, what I'm really moving out here is -3 times -1/9, or 1/3. So see how confusing this could get trying to complete the square? All right, but now I can complete the square on this. So that means it's a minus again. Funny. I'm going to use this sign, and that half of 2/3, which was 1/3, all squared. And now I've got two numerals over there, 1 and 1/3, that's 4/3. And finally I have it in a form where I can use my translations to graph it. All right. All right, so here's my basic points. Hopefully we can get those easily now. Okay, I'm going to move every point right 1/3. And then I'm going to multiply the y by -3 and move it up 4/3. Whew. Okay. So right 1/3. Okay. I'm at 4. So 4 times -3 is -12. It's way down here. And then it comes up 4/3. So I'm just going to put a point down there. We're going to imagine. Right? So this one is going to go right 1/3. Y is 1, so 1 times -3 moves it down to -3, and then I need to move it up 1 1/3. So it's about right there. Right 1/3. Okay. 0 times -3 is 0, so up 1 1/3. Right 1/3. Or I could use symmetry at this point, right? That might be easier. Let's just do that. Let's do this one more, and then we'll put that other one down there using symmetry. Right 1/3. 1 times -3 is -3. And then up 1 1/3. And then this point, because of symmetry, it's really not right there. But we're going to say it's way down here. And then I can draw my parabola. Notice it's very skinny because it's been stretched by a factor of 3 this time. And it's upside down because this is negative. Okay, and my vertex, we always said that's our most important thing. Okay, my vertex is 1/3, 4/3. Huh, what I want to notice is look at this. We could have always just known our vertex by looking at those 2 points, and maybe that's something you've already thought about or discovered when you were doing translations before. And like we said, that vertex is the most important piece of the graph. So now if I had it like this, I could just look at it and tell what my vertex is. Okay, this says identify the intercepts of the graph. And it would be really hard for me to identify the intercepts of this graph right now, the way I have it drawn. So, and this was really hard too, right? It takes a lot of practice, but it's kind of confusing, easy to make mistakes. Isn't there a better way? All right, there is actually. We have a little formula that says the x part of your vertex is at -b over 2a. Remember where, when we have a quadratic, we always consider this a, b, and c. So let's see what that would be if we plug that in. Okay, -b, so -2 over 2 times a -3 So why did I get -1/3 here? When I should have +1/3. -b over 2a. Let me check this math here a minute, guys. See? Signs, signs, signs. Look right here when I factored out a -3. I missed changing my sign. So even me that does this all the time, it's real easy to make a mistake doing this. Okay? So that's what it is. So our vertex really is at -1/3 because we should have been moving everything left 1. That's going to be a plus right there, and that's going to be a plus right there. So every one of these points, instead of moving it right 1/3, should have been moved left 1/3, right, left 1/3, left 1/3. So it's really over here. Okay. All right. Whoa, wasn't that a lot easier though? I have to remember a formula, right? Hey, you know what it is? It's part of the quadratic formula. If I were to continue writing plus or minus the square root of b squared minus 4ac, I'd have the quadratic formula, right? So maybe that'll help also. Oh, negative b over 2a. That gives me my x part of the vertex. Now, if I wanted the y part of the vertex, well, y, when x is negative 1/3, I could just plug it in. So let's do that. Okay, so I'm going to erase all of this, right? And here now, join me back again with doing it yourself. Okay, so I really don't need to do all this. Here's an option, but I don't need to do all that. I don't want to make that many mistakes. Okay, let's clear it. Okay, let's see. Okay, so if I'm going to graph these things, these quadratic functions, without completing the square, if it's not in if it's already in the form where I can do transformations, I'm doing that, buddy. You know, all I got to do is go over here and move my points. But if it's not, I'm going to do a different option. Okay, which means find that vertex. So x equals negative b. Okay, so negative, I'm just going to write it off for us. Negative b all over 2 times a. Okay, 3 negatives is a negative. Negative 1/3. The x part of your vertex is negative 1/3. To find the y part of your vertex, you just plug that in. So negative 3 times negative 1/3 squared minus 2 times negative 1/3 plus 1 is negative 3 times 1/9 plus negative negative 2/3 plus 1, okay, which is negative 3/9, right, multiplying straight across, which is negative 1/3 plus 2/3 plus 1. So 2/3 minus 1/3, which is 1/3 plus 1, which is 4/3, which we already knew it to be. But here's how I could get it. And you might be saying, oh my word, that's not that much easier. Well, in reality it is, but that's only when you wind up with a fraction, right? Which is rare when you're doing these, at least for this course, they make it nice. So I'm going to just list that up here because I'm going to need that room. So we know our vertex is negative 1/3, 4/3, right? Negative 1/3 and 4/3. So I'm going to find the vertex and I'm going to plot it over here. So negative 1/3 and 1 1/3. It's right there. Now, because this is negative, because it's negative, I know my parabola is going to be upside down. Right? So that means, well, now I need some points to see. I know the shape and I know where it goes, but is it like this? Or is it skinny? Or what? So if I just had a couple of points, okay, and the most important points on any graph, you should know this from graphing linear functions, are the what? The intercepts. The intercepts. Oh, well then let's find our x and y intercepts and boom, we'll have some points. Okay, so x-intercepts. X-intercepts are simply, remember what an x-intercept is. It's when y equals 0. When y is 0. So all I have to do is solve the equation when y is 0. So I'm going to try to factor this. I don't like that leading coefficient to be negative. Okay, So are there two numbers that I can multiply and give -3 that add to give 2? There are, but I can't just write it yet, right? Because the leading coefficient's not 1. So I'm going to rewrite my problem as 3x squared, and those numbers are +3 and -1. So I can write +3x minus 1x. It's still 2x. Factoring, here we are factoring again. Factoring, always for everything. Okay, factor out a 3x, and that leaves x plus 1. Factor out a negative, and that leaves x plus 1. So now I can factor out the x plus 1, and that leaves 3x minus 1. So x equals -1, and x equals 1/3. Now remember, these are points, these are our intercepts, so that's when y is 0. This is the point -1, 0, and the point 1/3, 0. So -1, 0, let me change that one, and 1/3, 0. Okay, and you're saying, uh-oh, our other one didn't go through, but remember I went the wrong direction. So we were all off a little bit on that. Okay. All right, so now what about my y-intercept? Oh, this is going to be the easiest thing ever. Remember, your y-intercept is when x is 0, right? That's what it means to be a y-intercept. So if x is 0, in other words, you're finding f of 0, and you just plug a 0 in everywhere. It's one. Hey, I can always just, on these functions, I can look right there and I know what my y-intercept is. Okay, so my y-intercept is 1. Because these parabolas are symmetric, and this is my axis of symmetry right through here, I know there's another point right across here. And there's my parabola. Now I got a comment for you. Last time we had a point way down here to tell us how skinny this thing was. So don't draw more than what you know, right? Because it's really tempting to kind of draw this out this direction. Okay, but we know from the other graph where we actually had a point down here that it's real skinny. So just draw what you know. Draw what you know. Okay, and now I have my intercepts. Oh, don't forget, this is also a point when x is 0. So there's your y-intercept, and here's your x-intercepts. Okay, much easier than that completing the square, right? All right, it is, trust me. Okay, well let's try it again then, and let's see. Okay. Oh, here's just some general information. Again, if you want to pause this and read it, it's just telling you if your vertex is HK, then the axis of symmetry is x equals h. We've already discovered that. It opens up if your leading coefficient is positive, and down if your leading coefficient is negative. Okay. That's about the stretching and shrinking. That tells us where the y-intercept and the x-intercepts are. So all the stuff we already just discovered. There it is, nice and listed for you. And also, here, if you want to write these down, here's your steps for graphing every quadratic function that's not already in the form that you can use transformations on, right? Okay. So let's do those steps again and see how it comes out. Okay, so first thing I want to do is find my intercepts. So the intercept, not the intercepts, the vertex is at -b over 2a. I got to memorize that formula, right? -b over 2a. Don't forget that. So -6 over 2 times 1 is -3. Okay, so the x-coordinate of my vertex is -3. And then the y-coordinate is just if I find out what y gives when x is -3. So -3 squared plus 6 times -3 plus 5 is 9 minus 18 plus 5, which is -9, right? -9 plus 5, -4. So that's the y part of my vertex. Okay. So I'm going to plot my vertex. -3, -4. Okay. And then I need to know if it opens up or down. If it opens down, I need to change my scale. But because that's positive, it opens up. So I'm just going to go with it like this. Okay. So I know it's going to go like this. So I need my x-intercepts. Okay. So the x-intercepts is simply where I set the function equal to 0 and solve it. Hey, I get a shortcut on factoring this one. So my x-intercepts are -5 and -1. -5, 0, -1, 0. Remember, that's a point. If they say what's the intercept, don't just say -5. It is the point -5, 0. So 1, 2, 3, 4, 5, and -1. Now at this point, I better stop and make sure it's symmetric. Y'all see me, you know, it's easy to make mistakes for everybody. So, but look, here's my symmetry, 2, 2. Okay, I feel good about that. If I missed a sign or something and I had this one over here, I would know something is wonky, or worse yet, if this one was over here and my vertex down here. So it's nice to double check at this point. All right, now I need my y-intercept. What's my y-intercept? Hey, I can just look right there, because if I plug in a 0, so 1, 2, 3, 4, 5. Okay, and if I use symmetry, I know there's another point that's 1 away from this one right there, so 1 on the other side of that one. And then I can draw. Imagine I went through that. I'm not going to erase it. Y'all just imagine, yeah. Okay, so there's our graph. But then don't forget, it has to give the vertex. So our vertex was -3, -4. Right? The domain, I know the domain is -infinity to infinity without even looking, because it's a quadratic. And the range, right, because it opens up, so it's the y, range is talking about y, so it's -4 to infinity. Okay. The axis of symmetry is x equals the x-coordinate of the vertex, -3. Okay, and the intervals where it's increasing and decreasing, it's increasing from -3 to infinity, and decreasing on this side, this now, from -infinity to 3, to -3. Okay. All right. So getting the graph this way was much easier, right, than having to complete the square? Pretty easy. And most of the time it is. Sometimes it's not easy either way, like that first one we had, or that one right before this one. That wasn't easy either way. But that's pretty easy. Let's try it again. Okay, so we're going to graph this. It's not set up where I can use transformation, so the most important thing is to find the vertex. Okay, so that is x equals -b So negative negative 4 is 4 over 2a. So that's 1. Okay, so let's plug in f of 1 is 2 times 1 squared minus 4 times 1 plus 5, or negative 2 plus 5, 3. So my vertex is 1, 3, right? 1, 3. Okay, 1, 1, 2, 3. Now I need to know if this thing opens up or down, and because it's positive, it opens up, and hey, look at this, right? It opens up. There's not any x-intercepts. Okay, there's not any, so I get to skip that whole step. If I didn't catch that and I set this equal to 0, I'm going to get complex numbers. So that's my clue. Oh man, I can't graph complex numbers on a real number coordinate system. So that's my clue that, oh, that's because there's not any x-intercepts. But it'd be nice to find that out before I had to do anything, right? And I can tell just by looking. So next step, find your y-intercept. 1, 2, 3, 4, 5. Because of symmetry, there's got to be another point right here. And if that's all the points we can get, that's all the points we can get, right? It's not ideal. I like to have 5 points, but hey, there's not any x-intercepts. Okay, then we could answer the same thing. What's the vertex? We've already stated the vertex. The domain, of course, is negative infinity to infinity, always on every parabola. The range is from 3 up, so 3 to infinity. That's a bracket. Okay. The axis of symmetry is an equation, so it's got to be x equals, and it's x equals that x coordinate. Okay. Intervals where it's increasing and decreasing, it is increasing from 1 to infinity and decreasing from negative infinity to 1. Awesome, right? Totally. Totally. Okay. All right. Let's try it again. Make sure we got everything covered. Okay. So x is negative b. So negative 12 is positive 12. Negative b over 2a. So this time a is negative. So this whole thing is negative. 12 divided by 4 is 3. All right. So f of negative 3 is negative 2 times negative 3 squared minus 12 times negative 3 minus 16, or negative 2 times 9, negative times a negative, so plus 36 minus 16, so negative 18 plus 36 minus 16, so this is 18 minus 16, or 2. All right, so my vertex is at negative 3, positive 2. All right, I'm just going to get rid of all that so I have space, right? Negative 3, positive 2 is my vertex. What happened to my, like that? Okay. I don't know where that pencil came from. All right. Negative 3, positive 2 is my vertex. It's kind of annoying me. Sorry. Okay. And it opens down, so there are x-intercepts. So I need this negative 2x squared minus 12x minus 16 set equal to 0. Okay, and now let's divide everything by negative 2. By the way, I can't do that up here, right? I can't do that if I have a function, because that would mean dividing both sides by negative 2, and then I'd have y over negative 2, which isn't actually my function I'm trying to graph. So be careful about that. I can only do that when I have an equation. So that would give me, if I divide everything by negative 2, x squared plus 6x plus 8 equals 0. Okay, so x plus 4 and x plus 2 are my factors, meaning x equals negative 4 and x equals negative 2. So that is negative 4, 0. Remember their coordinates, and negative 2, 0. All right, 1, 2, 3, 4, 0, and negative 2, 0. Double check to make sure it looks good and symmetric, and it does. Y-intercept is negative 16. That means somewhere way down here, right? I'm just going to put it right here for our sake, but it's even farther down than that. And that means 2 units away from this point, using my symmetry, there's another one way down there. And then draw the graph. Okay, we have the vertex listed. The domain is negative infinity to infinity. We know that. The range, in this case, though, is negative infinity up to the y coordinate. So up to 2. Okay, the axis of symmetry is x equals negative 3. And the intervals where it's increasing and decreasing, it's increasing from negative infinity to negative 3. And decreasing this time from negative 3 to positive infinity. Okay, nice. Let me know if you have any questions. Yay, the pencil's gone. Well, maybe because I don't have it on a pencil. I don't know, but I hope it's gone this time. Okay, one more. You're going to have a couple of applications. The nice thing about them is most of the ones are ones we've already had examples of. You know, I think you have another box one where you cut the corners out of a box and fold it up. There's an example of that when we were doing quadratic equations. I think you have a projectile, you know, that's shooting up into the air. There's an example of that when we were doing quadratic equations. But this one's a little different. A college campus has plans to construct a rectangular parking lot on land bordered by one side by a highway. There are 640 feet of fencing to fence the other 3 sides. Let x be the length of each of the 2 parallel sides. So if we have, yes, the pencil's gone, a highway right here. And they want to build a parking lot, rectangular parking lot. And they said let x be these 2 parallel sides. Okay, we have 640 feet of fencing to fence these 3 sides. Express the length of the remaining side to be fenced in terms of x, so this side. So if this is 640 feet total, then this is 640 minus 2x values, right? Whatever this length is and this length comes off of the 640. So that's A. Determine a function that represents the area of the parking lot. Well, area is just length times width. So the area of this parking lot must be x times 640 minus 2x. Or, distributing that x, we get 640x minus 2x squared. And notice if I rearrange that to put it in descending order, there's me a quadratic function, right? That's a quadratic function here, but here it's just in descending order like we're used to seeing them. So that's my function that tells the area of the parking lot. So what dimensions will give a maximum area? What is this area? Anytime we have a quadratic, right? A quadratic, and they were asked a question about the maximum or minimum, basically they're saying what's the vertex? Remember, that's what the vertex is. It's either that maximum or that minimum. And because this is negative here, we know it's upside down, so that is the maximum. So really all it's saying here is find the vertex. And that's handy because the vertex is, the x-coordinate is negative b over 2a. Negative is positive, so 640 divided by 4, what's that, 160? Yep, 160. Okay, so that's x, right? 160. So we can either plug that 160 in here and find out the other side, or, you know, I can plug it in here. Either way, be easier to plug it in right here, wouldn't it? So 640 minus 2 times 160. So that's 640 minus 320, which is 320. All right, so here's the dimensions of your parking lot. Cool. Okay, guys. Let me know if you have any questions. I'll see you next time.